reason I spent all that time on the analysis, and Rob Brown helped a lot from a user perspective as to what was important to him, was that I was just dying to know how close I was and if I could give up the ghost and call it done. So, and yeah. Okay, well then, if so, then I'll go ahead and share. Okay, here we go. Can you see the Ronchi calculator?
Yes.
Oh, excellent. Okay, so this is Ronchi calculator, and I've already entered in. Can you see where my mouse is going? Move it back and forth.
Yes, I can.
Okay.
Yep.
Yeah, so I've entered the mirror diameter 16. You can enter either the radius of curvature, the focal length. In this case, I just put in the focal ratio of 3.3. And Pierre says that his grading frequency is 84 bars per inch.
Yep.
So I wanted to say something first. So that's all you have to enter is just those three. And in fact, we only actually need to know two parameters, which I find astounding. And I want to just go over that for a moment. So if we come down here, look at this zoomed in picture of how the zones from the mirror focus. And as we know, the edge zones focus further out when the mirror is parabolized. And as you get closer to the center, they focus shorter or closer to the mirror. And the mirror's diameter and focal ratio create a unique set of numbers here, a parabola that is then projected through the grating. Do I have a picture of that? Yeah, through the grating at some particular offset. Well, actually, since the grading can be specified in number of bars per aperture, we actually only need two parameters, which is the total grading bars across the aperture, which is usually a really large number, and the focal ratio. And I just find it incredible that that's all we really need. But what we're really doing is defining a unique parabola and then using the grading at a particular offset to zoom in or zoom out from that. So with that in mind, let me go back. Here we are. So here's Pierre's mirror. And let me go and so here's his Ronchigram I grabbed from online. And I think it's amazing that we can do this around the world. He just sends a Ronchigram and we can analyze it so well, so accurately.
It is.
So I'm going to copy that to the clipboard, come back here, and if I do it right, this is a Windows machine, paste it in, and there we are. Okay, so things don't quite line up. So he took his at some particular offset, and now I have to go find what that offset is, but no worry. We'll just zoom in and out here until we match. Okay, that's pretty close using the slider. And then I'll just go a little bit more using the plus and minus to refine it. And there we are. And you notice that we have some artifacts. The calculations are intense. So there are interpolations or pixels that are skipped over. So I have this fill factor here, and we'll just go from 2 to 3, and that makes them go away.
Oh, that's new.
Really? So you can see that if I turn them off completely, there's a lot of pixels that are missing that the software needs to interpolate and fill in, but that will slow it down. So I usually don't set this till after I've got stuff set up. So you can see that he's got his mirror pretty close, but what we want to do is find out exactly where his is at. And so I've seen Dale Easton in person at a conference many years ago back in the Midwest. And he was a machine. He'd grab a mirror and put it up there, adjust his bath interferometer, and then, smile and say, ta-da, here's your results. Next mirror, grab the mirror, put it up there, adjust the bath interferometer, smile, click, here's your results. It's just astounding. Well, I've seen one other person do that too. Carl Zambuto can Foucault test like you can't believe. I've seen him take a mirror, adjust the tester, and read the zones so accurately. It's just incredible, those two. So clearly, I'm not quite at that level, because one of the reasons I went this route many, many years ago was that my Foucault tests of my mirrors, particularly on the large fast ones, kept ending up with an overcorrected mirror. I was doing something systematically wrong and looking at the shadows, or maybe the formula I used didn't use enough expansion terms, but didn't work for me. And the beauty of the Ronchi with the digital image is that you don't have to guess where the Foucault shadows are or anything. They're just right there. But now we have to figure out exactly where the Rockies are. So we're going to go thin his bands. And there we are. So we can adjust them just a little bit more. The idea is to get the red reference lines exactly set. So we'll go just a bit more on the plus. There we go. Okay, so any questions so far or comments? So we can look at this. And before we get to the analysis, let's just look at the zones. So in fact, what size of center obstruction are you going to have? Like a 4-inch diagonal pier?
Yeah, 4-inch. Yeah, 4
Okay, so
inch.
let's put that in. There we are.
Where did you do that? Oh, central
Central
obstruction. Oh, I
obstruction,
see. Oh, okay.
right?
Neat.
Yeah.
Okay.
So you can see the 25% circular ruler is here. The 50% is a little darker red, and then the 75% here. So when we deparabolize this to null it, then it necessarily shrinks the 25 down to here, the 50 here, and the 75 here, which is kind of startling when you first see it. But then on the other hand, the edge zones are pretty important in big mirrors and fast mirrors. And so we'll take advantage of that. But every part from this rim here on outward is the 75% zone to the mirror's edge. Okay?
Now, what you just did, adding the central obstruction, can you put that back to how it was before? Just it was 0 probably. Okay, so it's normal that the circles are not the same size on the nulled version than on the normal Ronchi screen version.
That's right.
I wonder
So when you
about that. Okay.
deparabolize it, you in effect take those curved center bands and make them straight. So by necessity, this curved area here, which is just past the 50% zone, when that's
Yeah.
straight, is going to be down here.
Oh, I
It's
see.
going to
Okay.
come here. Right.
Okay. I'm learning a lot
That's
here.
fine.
Thank you. Yeah.
Right. And by the way, I prefer to be just inside the radius of curvature with 6 or 7 bands. Normally you think, well, we know when we start test with a Ronchi grading that we want to get just a band or two and then hope that between the scene we can kind of get a sense with our eye where what the mirror is, if it's overcorrected or has zones or something. So now what was I going to say with that? But here we actually want more bands because that gives us more analysis points. So that's backwards from what we're kind of used to with the Ronchi.
Okay.
Okay, any other comments? All right, so we can see here that he has some inward curve, so we know that's undercorrected.
Yeah.
If it were overcorrected, it would still be showing some parabolization, but it's not. And we know that this is pretty close to the 50% zone. So we'll just say, take a first guess that this is a 60% zone that is a little undercorrected. So coming over here then, we're going to take a look. And first thing we're going to do is I'm going to just use, no, let's use a zonal ruler. So you can decide how many zones you want and where. You can use 0.1 increments, which fills them all out like that. That's a lot. You can use the Ronchi bands themselves, which is usually what I do. In this case, well, maybe we'll just do this. This would be fine. So these correspond to where the Ronchi bands are. So we know that something just around 60%.
Excuse me, Mel.
Yeah.
Mel, when you say use the Ronchi bands, you mean at the intersection of the Ronchi bands and the 25, 50, 75% zones? Is that
Yes.
what
Right.
you're, okay, okay.
Right. So for instance, the first zone that comes up is zonal radius of 0.55. And we can see over here that this first band is indeed just past the 50% mark.
Right,
So all this software says is that, well, you have bands here, and it would be most accurate if we adjusted on the bands.
right,
So that's what we'll do. And we know that about around here is where we're a little undercorrected. So what we're going to do is, because we are undercorrected, we have to add more correction to help the mirror out. So we're going to go and bump this up to 1.05 and go to 0.1. Oh, now do you see them straightening out there a bit?
yeah,
Okay, let me reset back to 1. There. Now I'll go and bump them up. Okay, now notice how the bump is actually further out than that. So let's lower this down and maybe even, maybe we'll keep it about here or so. And also, we don't want them extending that far. So we're going to put this zone maybe back at 0.6 or so. And that looks a little closer. Maybe we'll up this just a bit more. And so we're going to save these corrections because I want to reset the corrections to 1. Yeah, so and then we'll restore the corrections. So you can really see here we go. And we'll restore back the corrections. So it's not perfectly straight, but it's straighter than it was. And that's all we're doing. So again, his zone is somewhere around 0.5, 0.6. It's undercorrected because we can see that the mirror looks underparabolized. If it were overparabolized, you see the bands curving outward. So we have to add correction to make up for it here in the table. And we adjust it and play with the zones around it. Maybe this one here needs to maybe go up to 0.4 or so. I don't know if that's making it any better, but that's straighter. Not perfectly straight, but it's straighter. And
And
maybe
one question, why does it change color from green to red on the right column there?
oh, but that's the Mirepoix tolerance. So you're
Okay.
exceeding the Mirepoix tolerance for that zone.
Okay.
So remind me to say something about that, which I think is pretty important.
Okay.
But not right now at this moment. So it's not perfectly straight, but it's a lot straighter. Okay, so let's see. We know that we've exceeded that. That doesn't mean that the ML tolerance is bad overall. It just means for this one zone, because we know we can adjust the ML tolerance envelope up or down a little bit, to get them to fit in there and so on.
Mm-hmm.
So I just found the calculations to do that to be not worth the time. So you're out of compliance in this zone, but that doesn't mean if you don't adjust all the zones downward that this zone doesn't come into compliance.
Oh.
Okay, and in fact, you're just at 1.2. So you're right on just barely past the edge of ML. And probably if you adjusted them a little bit, you would fall within range. But
Right.
notice that you're just a 10th wave here. So you
Yeah.
probably have a snap focus, but you would probably see that 60% zone is undercorrected as you defocus the star. It'd be a little brighter above focus compared to below focus.
Hmm.
And then as to polishing actions, this is just like Texero. You can decide to lower the centers. And because this is a slope test, once you lower a zone, you have to lower all the zones interior to that.
Mm-hmm.
Or you can decide to work the other way out. You can leave the center alone and lengthen the exterior or outer zones to match the 60% zone that isn't quite low enough.
Okay, so that's what the chain slopes choice
Right.
is just
Yeah.
below there.
Right.
Oh, I see. Okay. Okay, so I've been doing it wrong because I've been working the 60% zone, but not the interior.
Well, so let's turn it off. There you go. So that's what you're doing, Pierre.
Yeah, okay.
Right.
But
So if you have a sub-diameter lap, do this. Lower
well,
the
that's what I
60%
tried.
zone.
That's what I
Right.
tried, and it kind of worked, but
Right.
not that much.
Now, if you keep doing that, ultimately the center should come up a little high because you're not lowering it down too.
Uh-huh.
But the biggest issue right now is that 60% zone is just a little high.
Right. Okay. I see.
Okay.
Yeah.
So let me see if I have it on here. Oh. Sorry about the scrolling. It's going to make you crazy. Okay. So we're getting down to the pixel level, but you can do more than that. So let's go up to 600. Okay. So
Mhm.
now you can see the differences much more starkly. And we could even go bigger if you want to see more difference. So there's a lot of resolution, even in that just quick Rockygram that Pierre supplied online, um, left for us to analyze with.
Just a question. What did you just do with Ronchigram size? You just make
Yeah, just increase it. Everything
the size of
resizes
the,
proportionally. Yep.
okay.
So now you can see, oh yeah, so you could adjust it further. I'm just saying that I just do 400 to get everything onto the screen, but if you want to get really exact, uh, you can increase it and get more resolution out of it. The bands that we can extract from the digital image from the thinning algorithm is pretty accurate.
Okay.
And in fact, if we come down here and look at the example, um, here we go. So this is 12" of 5, a theoretical example showing 1/5 wavefront undercorrected. And let's come over here and we'll just make this 800. And then we'll scroll back this way. And you can definitely see the 1/5 wave. It's not hard to see 1/5 wave. And from my viewpoint, on a large fast mirror to have a test that will get to 5th wave, 10th wave, that's incredible. Because now I can take it to star test to verify and decide, if this is as good as I can make it, or if I can chance working further.
Right.
Okay, so I mentioned something about the ML, and I was going to scroll down here and see if I had it in this web page. Oh, by the way, you can do a grid too. So if you don't change your tester at all, just rotate carefully the grading, integrate the two images. You can do a Hartman test out of it. Oh, and Rob Brown started using it as a wire test here too. So anyhow, yes, so this is it here. And I'm gonna, shrink the screen a bit. Okay, so here's something I've discovered, and I just want to share this. Well, let me start down here. Okay, so here's an ML measurement that I took. All right. So, you're just on the test stand and it's not zeroed out or anything. So what you normally do is you come down here and you try to fit it into the envelope,
Right.
right? So
Yeah.
In Pierre's case, his 60% zone would be just above the red, maybe on it. But I found that isn't accurate. Indeed, this is more representative over here. And it took me a while to figure out why that's going on. And this is why I think it's happening. So when you take a star test and you focus, you are necessarily working on the outer rim of the disk of starlight. And as you go into focus and go past and then go back again and then go past again, and you finally center on and you get that star to the point that the seeing and magnification allow you, what you're really doing is focusing the mirror's edge. And then you see what goes on with the rest of it. So I have come to the opinion on large fast mirrors that this is actually an inappropriate analysis that does not reflect reality. Instead, if you do this and you do the star test, you'll see that that zone is a little high, higher than what you might think it is. And so here we go. So let's start on the left. All zones perfectly focus, and everything's great. Notice the focus tolerance, which is not much on F3, but it does exist. Now here we have a high center zone, but it could be a high 60% zone. Notice that the focus depth, that the center still barely gets within the star disk. So from the viewpoint of a snap focus or even a high power star test, this mirror would be okay, but the diagonal breakout would be like, 1.5 to 1 or something like that. Okay.
Mhm.
Now let's look over here where the center is even higher than that. And now we're in trouble. If we take a look at our focus depth, that the center zone focuses or makes us fall into, the focus depth is much shorter, trying to get that center and edge both focused at the same time. This I found is not a good star test. This is okay. This is perfect on the left. This is acceptable. This on the right, I do not like in fast, large mirrors. So I've learned to take the ML numbers and leave them alone at the edge. And then if I can scroll back up, the way you do that then is you make sure that you leave the corrections out here as ones, or you make another way to put it is you try to get these red reference marks to line up with the outer zones and not the inner ones. So line up your red reference with the outer ones, not the inner ones. And then it all magically works. And that is it. So Pierre,
Okay.
you are going to, you're just so empowered now. Now you just now leave it to the masses to figure out how to execute it and make it work, right?
Yeah, well, okay, then I'll be able to try those new tools.
Yeah. And again,
So,
I'm not
yeah,
claiming that it's 1/10th wave versus 1/12th or 1/8th. I'm just saying it's ballpark to give you a feeling for where you're at, and you're just barely within the snap focus. So
right. And if I play around with the ML zone, I might be able to find a fit where it would the red bands would disappear, the red text would disappear, but
right.
I would still
But I
be
don't
really,
think it's
really
valid because I don't think you should be playing. Like for instance, if we took this 0.4 zone and we get it down here. There we go. So now it's turned yellow and pretty soon. Now it's red. So we could fix
right.
this by adjusting them, but I don't think that's a good idea. I think we
Yeah,
should leave these at ones and then just accept reality, what is going on, what this is telling us.
right. And work the surface of the mirror instead of wishful thinking.
Right.
Yeah. Okay. Okay. That's great. So I will that thank you very much. That helps me understand a lot. I hadn't seen the some of your different options. I saw them, but I didn't know what they meant, and now I know.
Right. And there's a lot on here. Let me just share it again. Share screen. Okay. So see all these options in here. So this
Yeah.
is all Rob Brown's fault because he wanted to be able to change the band color and the background color. And he said his eyes hurt if he couldn't change the application background color. So So you can razz Rob that all these stuff in here, but it brings up the issue of what are important adjustments to make in here and which ones really are not. So the null fill factor, if you start to see those artifacts, just bump it up to 3.
Okay.
Thin the bands. If you want, you can just click on the button here or do this. And then really it's just mirror diameter, radius of curvature, focal length, focal ratio, and then a grading frequency. And then you play with the adjustment to zoom in or out. That's all you have to mess with.
Right.
Oh, occasionally when you do your Ronchigram, you're going to find it offset a little bit. Sometimes people send them to me that way. You can slide them back and forth like this if you need to. In Pierre's case, his was centered to the pixel, so I didn't need to do that. That's about the only one I really play with too much.
Right. Okay. Well, I normally end up, I don't know, my pictures, I had to play with the width and the height and the offsets a bit, maybe 5 or 6 pixels, whatever the number is. But I'm surprised you didn't have to, that you could just dump it in and it worked. But
It worked.
okay.
Well, like you might recall that recently on the Oregon Scope Works, Tay from Portland, Oregon, has been posting Ronchigrams, and they're pretty tiny. And so, of course, he's going to have trouble getting them really centered. The best thing he did was post a video of them sliding it back and forth, because then I could pause the video at just that one perfect picture and made it easier.
Using a full-size lab.
Yeah, yeah.
Okay.
I just jump in. I've got to go for a work thing. I'd just like to thank Mel and Pierre and everyone for organising this, and I'd just like to the light bulb moment for me was to work out what the zones were on the nulled image. I hadn't quite appreciated where the 50% and 75% zones were. I was assuming they were linear, and that meant some of your comments, Mel, didn't make any sense to me at all. So that's really the main light bulb moment for me today, and I thank you for that. It will make more sense for me. But anyway, thank you very much, Mel. Thank you, Pierre, and I'll catch up with you, Rod and Dale, and Peter. Thank you. Sorry, I have to go, but it's been fantastic.
Bye-bye.
Thank you.
Thank you.
Go too.